welcome back guys. So in this particular session what we'll be covering is partial correlation and then multiple correlation as well. So what we've been given is that we've been given the number of observation which is 10. Okay, so I'm not quite sure if you can see it from there or not, but it's a bit smaller, sorry about that. And then x1 is 10, x2 is 20, x3 is 30, x1 square is 20, x2 square is 68, x3 square is 170, summation x1 dot x2 is 10, summation x1 dot x3 is 15, summation x2 dot x3 is 64. Okay, so what we need to find out is that partial correlation between first variable and third variable, keeping 2 as a constant. Okay, eliminating the effect of 2, that means keeping it as a constant, right? So second thing that we need to find out is multiple correlation between x1, x2 and x3, assuming x1 as the dependent variable. Okay, so let's solve it. So first of all, what we need to find out, since we don't have the correlation between first variable and second variable, or first third second third, we don't have that, we need to find it out. Okay, so R1 2, right? So what's our example? So we solve this by n times x1 dot x2 minus summation x1 dot summation x2 under root n times summation x1 square minus summation x1 whole square. Okay, so again the same thing but for x2. Okay, whole square, right? So when you are solving this, let's put in the values. N is 10, right? N is 10. What is our summation x1 dot x2? It is 10 again. Minus, what's our summation x1 dot x2? It's 10 and 20. 10 into 20, right? And then again under root, our number of observation is 10. What's our x1 square? It's 20, I guess. 20 minus x1 whole square is 10 square. Right, again over here, same thing. Let's open it. x2 square is 68. 68 minus x2 is 20 whole square. Okay, so let's just compute it quickly. 100 minus 200 divide by, so 200 minus 10 square is 100, right? So this will be 100 dot, this will be 680 minus 400, 280, right? 280. So this will be minus 100. Okay, I'll just use a calculator. So minus 100 divided by 10 divided by under root 280 minus 605.76. Okay, so what we will do is that we can round it off as well. Minus 0.60, I just rounded it off. Okay, so this is for correlation between first variable and second variable. Now we need to find out correlation between first variable and third variable as well. Okay, so what I will do is that since we don't have much space over here, I'll just write this value at the top. Okay, so R12 is equals to minus 0.60. R13 is equals to, we don't know that yet, right? So let's figure it out. So R13 is equals to R, not are, it's n times summation x1 dot x3 minus summation x1 dot summation x3, okay? Always remember it's summation x1 dot x3 and then under root n times the first number from here, x1 square, okay? Squaring it off, and then minus summation x1 whole square, okay? So these two are two different things. This is x1 whole square, whereas this is, x1 square, and then this one is x1 whole square, okay? So n times summation x3 square minus summation x3 whole square, okay? Number of observation 10, x1 dot x3, it's 15 minus, what's our x1 dot x3, so 10 and then 30, right? 10 and 30. So this will be 10 into, what's our x1 square? It's 20. 20 minus x1 whole square, that means 10 square, right? 10 square. This one is 10 into x3 whole square. x3 whole square is 170 minus, what's our x3 whole square? 30 square, right? So what we will get after this is basically 150 minus 300, that will be minus 150 under root, or no, under root, it will be 200 minus 10 square will be 100, so that will be 100, right? Under root 100, under root 100 is 10, right? 10 into, so what is that? 1700 minus 900, how much will that be? So let's just compute it quickly. Divide by 10, that's 150, divide by under root 1700 minus 900, right? So this will be 0.53, okay? 78. Okay, so 0.53 is our correlation. So what about 2 and 3? So same thing again, let's change the formula. The formula is same pattern again, just the numbers are different. Is n times summation x2 dot x3 minus summation x2 summation x3 under root n times summation x2 whole square summation x2 whole square and summation square, okay? N times x3 square x3 whole square, okay? So let's just put in the values quickly. So x2 x3 is 64 minus x2 and x3, right? x2 and x3 is 20 into 30. 10 into x2 square is x2 square 68 minus x2 whole square is 20 square, right? And then again this thing is 10 times x3 whole square is 170 minus x3 whole square, right? x3 whole square we have computed R13.2. Now what we will do is that we will basically find out our first requirement, which is partial correlation between x1 and x3, eliminating the effect of 2. Okay, so 2 is a constant, your effect of these two variables. Okay, so I mean one variable on the other variable. So what we do is that, so our formula is n times x1 dot x3 minus summation x1 dot summation x3, right, under root n times summation x1 square minus summation x1 whole square, right, and then again multiplied by n times summation x3 square minus summation x3 whole square. Okay, so that's a whole square, and then our number of observations is 10, right? Let's look at the figures. X1 dot x3 is 15, okay, into 15 minus, so 10 and then 30. 10 into 30, right? 10 into x1 square is x1 square 20, right? Minus x1 is 10, whole square is 10 square, right? 10 into x3 square, right? 170 minus x3 square. x3 is 30 square, right? So let's just compute it quickly. Sorry, I think we will get that value. Let's compute it anyway. Minus 10 into 30. This will give us minus 150 divided by under root, or what I can do is divide by 10 under root 1700 minus, that is 800, right? So 0.53. How did that differ? Let's do it one more time. 150 minus 300, that will give us 150 divided by under root 200 minus 100, and then again divide by under root 10 into 170 minus 30 square, right? So 0.53. Again, let's check the answer first. For 17, right? 0.6. Should be minus, right? 0.53. Okay, minus 0.53. So it should be minus 0.53. 0.53, okay? Because 150 minus 300 will be minus 150, so it will be negative, okay? So the correlation between 3 and first variable is in negative, okay? So what we need to find out next is that multiple correlation between x1, x2, x3, keeping x1 as the independent variable, okay? So we know, right, R1 dot 2 3 is equals to under root open R12 square plus R13 square minus 212 R13 R23, okay? And then divide by 1 minus whatever this number is at the behind, R23 whole square, okay? 1 minus 0.085 squared. R12 is minus 0.6 minus 0.6 square plus R13 is 0.53 square minus 2 times minus 0.6 times 0.53 times this is not 0.53, yeah, it's 0.53. Right, and then after that 0.085. So how much do we get? The root is 0.6 square. Let's open the bracket first of all. So 0.6 square plus 0.53 square minus, oh no, plus, because minus plus, right? 2 into 0.6 into 0.53 into 0.085. Bracket close, divide by bracket open, 1 minus 0.085 square. 0.8366, that means 0.84. Okay, so yeah, it's a bit different. It's 0.76. It does not really matter because it's about the process, right? And then what I have done is that I have basically changed the values as well, right? Because I have rounded it off, so that's why this figure is a bit greater than the answer. Okay, so but still at the end of the day, what you need to remember is that how it is done, the process is most important than the answer in itself. Okay, so just a bit of difference in point and everything does not really make a big difference. Okay, so yeah, if you have any confusions regarding this kind of question, or even this question, please do comment down below. I'll definitely be happy to answer it for you. In the next session, what we'll be covering is how do we calculate correlation from the mean, okay? So that is another interesting thing that we'll discuss about. Until next time, bye-bye.